Okay, hi everyone. So today we are going to continue with 1.3 forces in equilibrium. So an object is said to be in equilibrium of forces when the forces acting on it produce zero resulting force. For example, here in this diagram, a boy is sitting reading a book on a table and the forces acting on the boy is in equilibrium. So the weight of the boy, which is acting downward, is equal to the net force acting upward. So when W is equal to the normal reaction, there is no resultant force. So that is why we said that the boy is in equilibrium. What happens when you have three forces involved? For example, in this situation, a medal is hung. So we have tension 1, tension 2, and the weight of the boy acting downward. The weight of the medal. So here, one method that can be used is triangle of forces. So for this method, it can show the equilibrium of forces when three forces are involved. So to do that, we are going to look at one example here. So the lamp is hung on a wall, and we have tension 1 and tension 2, which we call as P, and weight of the lamp acting downward. So from these three arrows of the forces, we can move the vectors around and form a triangle. Let's do some exercises. Okay, so for question number 1, so I have R, and then I'm going to move W, connect it with R, acting downward, and last one, connect W with frictional force. So that is your triangle of force for question 1. For question 2, draw tension 1 and then connect it with W and connect with the second tension T. When you draw the triangle of force, make sure the angle must be similar to the original drawing. Okay, for question number 3, so you have tension T, and then connect it with R, and last one, connect it with the second tension. Okay, so now we are going to look at a few questions to find the magnitude of the forces. So method number 1, to find the magnitude, we can use scale drawing of the triangle of forces. So let's use this question. First, you can draw a rough drawing, just like the exercise in the previous exercises. Draw a rough drawing. So your drawing is going to look something like this. T upward, weight going downward, and P going to the right, 60 degree. So this is your rough drawing. Okay, so to have a full scale drawing, a correct one, you should choose a suitable scale. So in this diagram, I think a suitable scale is 1 centimeter to 2 Newton. Step number 2, take a ruler and draw a straight horizontal line. This will represent your this will represent your P. Okay, but we haven't measured, we don't know the measurement of P yet, so just draw a long line. What we know is that T is 60 degree from horizontal, so we can use a protractor, find 60 degree, and then draw 4 centimeter line. Okay, so assuming this is 4 centimeter, next draw a straight line, straight vertical line from T and connect it until it touches horizontal. So now you have your weight and your P. Okay, next one. Measure the length of W and P and calculate the magnitude using the scale. Use your ruler to measure the length. So when you use the ruler, you will get W equals to 3.5 centimeter. And don't forget to convert back using the scale that you have used just now. So 3.5 times 2, you will get 7 Newton. For P, when you measure using ruler, you will get 2 centimeter. 2 centimeter times 2, you will get 4 Newton. So that is your magnitude. Okay, there is another way to find the magnitude of the forces, which we have learned in 1.2, resolution of forces. So here, if you want to find P and W, okay, let's find P first. So the drawing is T, P, and W. Okay, so T can be resolved into two components, which is Tx, Ty, and Tx. Since the object is in equilibrium, since the lamp is not moving, then we know that the horizontal components must be in equilibrium. Means P will be equal to Tx. And similarly, for the vertical component, Ty is equilibrium with W. So Ty is equals to W. So to find P and W, you have to find Tx and Ty. Okay, so let's resolve T into its respective Ty and Tx. Angle is 60 and T is 8 Newton. So you can form a triangle if you want. So by now, I think you already know, to find Ty, you can use sin. Ty is 8 sin 60. So this is taken from the formula sin 60 Ty over T. So when you calculate it using your calculator, you will get Ty equals to 6.93 Newton. Whereas to find Tx, you are going to use cos. So Tx is 8 cos 60 and you will get 4 Newton. Okay, so you know that Ty is equals to W if they are in equilibrium. So W is 6.93 Newton and Tx is equals to P, then P should be 4 Newton. Okay, so now let's check with the answer that you got in the previous question. So W that you got using scaled drawing is 7 Newton, but for calculation you got 6.93 Newton. Whereas for P that you got using scaled drawing is 4 Newton, but using calculation you got the same answer, 4 Newton. So we can conclude that using calculation method is actually more accurate. Okay, so in the next video, we are going to continue with another questions. Thank you.